Here we go. Next lesson. It is Law of Cosines. So we went ahead, we did Law of Sines. This is like the brother, the sister, the friend to it. Okay, Law of Cosines. There are two cases we haven't considered yet when it comes to information with a triangle. It is side, 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 and side angle side. And with those cases, Law of Sines can't be used. There's not enough information to find a missing measurement. Okay, in fact, there's just too many unknowns. So Law of Cosines is going to actually help us with it, and we'll be able to actually solve for those measurements using it. Now, what's going to be weird is I'm going to actually start by showing you what the Law of Cosines looks like. Okay, I'm going to show you the equations. So here they are. So Law of Cosines. And there are three versions to this. But they have the same pattern. You're going to see that in a moment. Okay, so there we go. So there's our three versions. Let's see if the camera can see that a little bit. Yeah, it looks okay. All right. But here they are. And as you can look at it, you can see that the cosine of the angle and the side that's across from it, they're on the outsides, right here, okay? So like if I have angle A and side A, they're on the outsides of this equation. And then what's in the middle are the other two side lengths. And again, they follow the same pattern. And then if you look at B, or B squared equals all this stuff, same thing. The angle and the side that cosine's with is on the outside and all the other stuff's on the inside, okay? So let's go ahead and just see, where does this formula come from? Let's do a quick little proof of it. All right, so we just draw a picture. So let's say I had this triangle. And point A is at the origin, 0, 0. We'll call this point C. I don't know what the coordinates are. I'm just going to put X, Y there. It could be any point. And then I got point B over here, which is some X coordinate. We'll just call it C. I can't use X again because I used it up there. You have too many X's. Let's go ahead and label the rest of it. So over here would be little b, here's angle A, over there is little a, here's C. Now, here's the deal, okay, what I'm gonna do, and this is where the Law of Cosines comes from, I wanna find the distance between these two, okay, I want you to keep that in mind. That's the goal I wanna figure out, is what's the distance between C and B? And to do that, I'm gonna take an idea from the proof I did with Law of Sines. I'm going to use the altitude to help me with it. And then what I'm going to do, okay, using the altitude, I'm not going to use the whole AB part. I'm just going to use A to this point right here, okay, where the altitude hits the base of it. So this is my initial setup. Now, how am I going to find A, the distance of A here, okay? Well, here's what I'm going to do. First, okay, I'm going to find what cosine of A is. All right, I'm only looking at this part of the triangle, the right triangle I just created with the altitude. So cosine of A is x over b, and if I solve for x, I get x is equal to b cosine of A. Now I'm going to repeat the process. Now I'm going to find sine of A. Okay, so if I look at it, sine of A, angle A, is going to be equal to y over b, and if I solve for y, I get b sine of A. Okay? Now, why did I go to that approach? If I want to find the distance between these two guys, I need to know what x and y are. I got to find their coordinates. So what I did is I created an equation that has x and y in it. And I used trig to do that. So now I have something for the x and y coordinates for this guy. Okay? So let me go ahead. I'm going to rewrite this. So we'll say, so our point C has the coordinates, and I'll put them in the actual brackets here. B cosine of A and B sine of A. Okay, so now we actually have a set of coordinates that we can use, and that's going to help us to find the distance between these guys. All right, so using distance formula, and let me just rewrite what that formula looks like. A little reminder. Okay, looks like this. And I'm going to take, well, we know what this is. It's this guy. And this, plug in the distance formula and simplify. And we're probably going to have to use an identity, okay? And you'll see that here in a moment. So let me go ahead and plug these numbers in. So distance would be A is equal to the square root. And we're going to subtract the x's together. So that's going to be x minus c squared. And we're going to subtract the y's, so it'll be just y minus 0 squared. Okay. Now I'm going to go ahead and plug in what we found x and y to be. So let's go ahead and do that next. I'm also going to do one other thing. If you notice in my original formulas, I don't have a square root there, so I'm going to square both sides. That way I don't have to worry about the square root at all. So let's look what's underneath the radical. So we're going to have, what is x? So x is b cosine of A minus c squared. And then y is b sine of A minus 0 squared. All right, just like that. Now let's simplify some things. Oh, I just said we're taking the square root out by squaring both sides. I still kept it there. Now I'm going to expand each binomial. Okay, so here's what we're going to get as a result of that. So if I expand the first one, I get b squared cosine squared of A minus 2bc cosine of A plus c squared. And again, I'm using that little trick that you learned in algebra where you double the first, multiply together and double it, and then square the last. And then over here, we're going to square what's left. It's just going to be b squared sine squared of A. You can kind of, just a little bit, you can kind of see, well, it looks like it's matching the first formula here that I have for law of cosines, but there's some extra things going on. And when you look at a long trig expression like this, look at where you could use an identity. And sine squared cosine squared is one of our Pythagorean identities, and they're close, and they're equal to 1 when you add them. So I'm going to group them together so I can use that identity. So we're going to get b squared cosine squared of A plus b squared sine squared of A. And then I'm going to rewrite the other expressions after it. Okay? So again, I moved this over so I can group it. They both have a b squared in common. So I'll factor it out. Okay. Hang in there. We're close. We are close. Okay, so looking at this, I can use the Pythagorean identity. That's a 1. So that just becomes b squared. And I got one final step, okay? Now again, if you look at the very first version of law of cosines, I'm almost there. The only thing I gotta do is bring the c squared to the front. I'm not changing it in any way, I'm just moving it. So for my final answer, we get a squared equals b squared plus c squared minus 2bc cosine of A. And there we go. We found it. Okay, that's one of my formulas for law of cosine. Now, I got 2 more. I could repeat the same process just by drawing a different triangle for each one and going from there. I'm not going to do that. Okay? You can kind of see the process of how we created it the first one, and you can see that you would duplicate that process continually. Okay? Alrighty. So, what are we going to do next? Well, let's go ahead and use it. Now that we derived it, let's go ahead and use it. And a lot of times, like, students look at this and they're kind of confused, like, which one of these do I use? You'll see. Okay, you'll see what all this kind of works out to be. So our very first example, I'm going to put in parentheses that this is a side angle side type of example. Okay? And the instructions I have, very basic, solve the triangle. Okay? And here it is. I'm going to draw it for us. There we go. So again, that's a side angle side type of problem, because I could see that we got a side length, the included angle, and the side afterwards. And I'm going to use law of cosines to figure this out. Now, if I were to, well, just temporarily, there we go, move this to where it's next to each other. And here's the goal. When you're looking at a side angle side, you want to go after the side length you don't know. It's across the angle you do know. Okay, that's what you want to do. So I want to go for this guy. So if I want to solve for b, I'm going to use the second form of this law of cosines. Okay, but even if you didn't know the second form, that's fine. You're still going to follow the pattern of I want to find the angle that's across from the known angle here in a side angle side scenario. So I'm going to rewrite this. I'm going to write the whole formula down. That way we can see it. So I'm going to use this guy, okay? And I'm going to plug values in. So I don't know b, that's what I'm trying to figure out. Okay, a squared 16, c squared 7. So there we go. Now, I will tell you, you want to be careful when you're plugging these into a calculator. You can plug this exact thing inside of it and get an answer. What I would do is at least give yourself a little bit of a breadcrumb trail and simplify a little bit as you're going through. That way, if you do make a mistake, you can go back and check quickly, okay, why didn't this work out? And that's what I'm going to show you here. So b squared equals, I'm going to square and add these together. I get 305. Multiply these together, I get 224 cosine 95 degrees. I wouldn't type that in the calculator because if this is a value that goes on forever, then taking the square root of it might tempt you to round before you take the square root, and you don't want to do that. So what I'm going to do is just keep it as is, but I'm just going to type the whole thing in the calculator to maintain accuracy. And we get b to be 18 feet. Okay, rounding to the tenths place, it comes up to be 18 feet. There we go. Okay, I have an answer. But I have, what, 2 more angles to find, right? And you have a decision you want to make for yourself here. What do you want to use? Can you use law of cosines to find an angle measurement? Absolutely. Could you use law of sines to find it now? You can. You actually have enough information to do that. So let me go ahead, I'm going to put a note here. So now, use law of sines or law of cosines. By the way, LOS, law of sines, LOC, law of cosines, I'm just abbreviating. Okay. To find one of the angles. And I'll put here your choice. Okay. And it is your choice. Law of sines, I would probably say would be more preferred, only because it's a little bit simpler, and calculation-wise, it's maybe 1 or 2 less steps. But again, you could use whatever you'd like. But we're going to use law of sines. Okay, so I'll circle that. So it's going to be sine 95 degrees over 18. Now, doesn't matter what angle I choose, I'll choose C. So sine of angle C over 7 feet. Okay, we're going to cross multiply, solve for this. So doing that, we get 18 sine of C equals 7 sine of 95 degrees. So sine of C is 7 sine of 95 degrees over 18. Then we're going to take the inverse. There we go. Okay, so drum roll. We get 22.8 degrees. Now, do we have to do that for, let's see, angle A? No. We know there's 180 degrees in a triangle, so I can add those angles up, subtract it from 180. So I'll just put, because I'm running out of space, I'll put it over here. So angle A, if you go ahead and do that calculation, you get 62.2 degrees for that guy. Okay? Now, one of the things I taught you guys in the past, I like to keep things organized because as you're solving these, you're gonna have work all over the place. And to me, it's just beneficial to keep it all in one spot. So let me go ahead and write all the information down. So this was 16, B was 18, C was 7, angle A was 62.2 degrees. Let's see, what was angle B? 95 degrees. And angle C was 22.8 degrees. So again, I just like to keep things all nice, neat, and organized because you have work everywhere. So it makes it a lot easier to see what your answers are. All right. Okay. So what do you think? Not too bad, huh? It's a little daunting because, again, you're still trying to figure out what this is and how to use it, but it gets better with practice. Let's keep going. Let's try another example. So let's try side, side, side. And here's the deal. I want to make a note of something with this next example. I'm going to leave this up here. I'm going to erase the stuff underneath it, but I'll leave that up there. Okay. Now, what I'm going to do is give you just a little bit of guidelines. For side, side, side. So first, use law of cosines to find the largest angle of the triangle. More on that later. 2, find the remaining 2 angles using law of cosines or law of sines. Again, it's our choice, okay, once we get to that. But just to make a little note of that, if you use law of sines after you do this, you're going to have to use a rounded value. And that might affect your accuracy a little bit. So you want to be careful on how you round things. Again, it's still your choice on how you want to do this, but just whatever choice you make, if you're using a rounded value, be extra careful. If you use law of cosines again, you're using the original information, and you're pretty much guaranteed to get an answer that's very close to what it should be. And then the last one, you're just going to find the measure of the third angle by, if you remember from geometry, what it was called? It was called the triangle angle sum theorem, which is what we did over here. You know, subtract everything from 180 so you can get the final angle there. So again, I just want to put just a little bit of guidelines there, and I'll revisit one, okay, when we start working on the problem. Because there's a reason why you want to go after the largest angle first. So let's look at a side, side, side example. Okay. Same instructions. We're going to solve each triangle. And I'm not going to have the drawing initially. I'm just going to give you the measurements. And remember, lowercase letters, they are representing the side lengths that we have there. Okay. Let me draw just a basic triangle. Does not have to be accurate. It's just there so I can put some pieces onto a picture. That way I can formulate my equations. So we have little a, that's 15. Little c is 28. Little b is 25. There we go. So we have none of the angles. So we're going to use law of cosines to find some of those angles. Now, what would be the largest angle here? Well, the largest angle is going to be across the largest side. So angle C is what I want to go for. So I'm going to look at this. I'm going to use the the last form of law of cosines here. So we got C squared equals A squared plus B squared minus 2AB cosine of C. Now let me make a comment here. See how the measurement you're trying to find is either going to be here or it's going to be the angle, right? That's the pattern. It's always going to be one of these. The other two sides follow this pattern, okay? That's always going to be. So typically with formula sheets, they won't give you all three variations of law of cosines. They'll give you one of them just so you know what the format looks like, so you can figure out what the rest of it is, okay? Now, I want to find an angle. So that means, let me get another color. I want to look for this guy. That's what I'm searching for. Now, I can, and again, this is entirely your preference, I can plug all the numbers in and then isolate this, use the inverse, I'm done. Or what you can do is you can rearrange the formula to make it easier to plug numbers in. Then you have less of a chance to make a mistake. I'm going to leave it up to you, whatever you'd like to do. I'm going to just show you what this looks like if I were to solve cosine of C first, okay? So instead of me plugging numbers in and then solving, I'm going to solve for this first. So I'm going to move these two over here by subtracting. Okay, just like that. And then to get cosine of C by itself, I'm going to divide both sides by negative 2AB. So I get this. Okay. Now, again, you can actually start typing numbers in now, but there's a lot of negatives going on. And again, my scenario is I want to try to eliminate any chances I can have an error. And negatives are a huge thing where you can have errors for. So what I'm going to do is I'm going to factor out a negative out of the top and bottom. And when I do that, these signs are going to change, but C squared becomes negative, and that becomes positive. So here's what I'll do. I'll show you that cancellation so you can see it. Okay, so I just took a -1 out of the numerator, -1 out of the denominator. It reduces. So this is the formula I'm going to use to calculate my angle. Now, some students like that, all right? Some students don't. They'll just put the numbers in and go from there, and that's fine. Whatever is going to be comfortable for you. Now, looking at this myself, I like this method just because here's the deal. If I have, let's say if I use the second form of cosine and I want to solve for an angle, it's the same setup where the angle and the side that are across from each other, this is always going to be negative and the other two is going to be positive. So if I wanted to find, for example, and I apologize for over-explaining, I just want to make sure you have an understanding. It's going to look like this, where cosine of B, and then this would be negative, everything's positive, and that's what it's going to look like. So it does have a trend. It has like a pattern to it. All right, enough of that. Let's just go ahead and plug numbers in. So here we go. I'll put it up here. Let's see. A was 15 squared. B is 25 squared. C is 28 squared. Over 2 times 15 times 25. All right, so there it is. You're gonna type that in your calculator, right? And again, I like to leave myself a little trail. So I'm gonna go ahead and simplify. Oh, nope. Sorry. Numerator, denominator. And then my last step is take the inverse. And we get C to be 85 degrees. So we found an angle. Probably thinking, wow, that's a lot of work for an angle. It is, because I was trying to explain setup-wise, but as you do it yourself, you'll find that you'll get faster with this. I'm still gonna find 2 other angles, okay? Now, it's our option. What we want to use, law of cosines or law of sines. I did law of cosines again, but if you use law of sines, that's fine. And it doesn't matter what we do next. So I found C. Let's try finding B. No reason why, but what the heck? We'll do it. So let's do it. All right, so cosine of B. Now, I kind of did it already over here. All right, by complete accident, I didn't realize I was going to use that again. But if I solve for cosine of B in the original formula, I get this guy. So why not? I went ahead and I did all the hard work, might as well use it. So cosine of B, and let's plug the values in. So there it is. Just like the other one, I'm going to simplify the fraction and then do the inverse of it. And we get 62.7 degrees. And just to emphasize, because again, I know a lot of people don't like rearranging a formula and then plugging values in. Honestly, it's not bad practice to do that anyway. But if you just want to plug the numbers in as it is and then solve for cosine of C, that's fine. Okay, now define angle, what do we got left? A. I would just subtract those values from 180, and we get A to be 32.3 degrees. And just like what I told you before, what I'm going to do is put all of it in a table because it's neat, it's organized. I like it that way. So 15, 25, 28. Let's see, 32.3, 62.7, and 85. And there we go. Questions? You're very quiet, so hopefully you're okay. You don't have any questions. Here's the deal. I told you I was going to come back to this guy right here. Why do we use it to find the largest angle first? Well, if you remember back with law of sines, we have that ambiguous case that could pop up, right? Where you could have two different cases, two different triangles, and you don't want that to happen when it comes to law of sines, okay? So there's that we have to contend with. But more importantly, cosine, the inverse of cosine, if you recall, I'll draw a picture here. The inverse of cosine gives you an angle measurement in quadrant 1 or quadrant 2. And that's a good thing because in quadrant 2, you could have obtuse angles, right? So let's say the angle is 120 degrees. Well, that's perfect. Okay, inverse of cosine will do that for you. Will the inverse of sine do that for you? Not necessarily. If you remember, the inverse of sine gives you two acute angles that are within quadrants 1 and 4. And that's not good. That's no bueno. So that's where it can get a little tricky, you know, like when you use law of sines to find this stuff. So, end of the day, what I'm trying to say is this. To find the largest angle of this triangle, law of cosines is perfect for it, not only because you can't really use law of sines to begin with anyway, but because it allows us to, if there is an obtuse angle, the inverse will give it to us. And then that means the other two angles have to be acute. So if you do, instead of doing this, if you do law of sines for that, that's fine. Because it's going to be acute angles. You don't have to worry about like ambiguous cases and all that stuff. So it allows us to make sure that our calculations are sound and we don't get anything too weird, okay? I'm sorry, that was a lot of explanation, but hopefully that makes sense to you. Okay, I want to do an application problem with law of cosines. So let's go ahead and tackle that. Again, I'm going to leave the formulas up here. So here it is. We have a Coast Guard ship on a routine training run. Leaves the base at 16 knots on course of north 82 degrees east. 3 hours later, we have a distress call that comes in from a cargo ship that is located 180 nautical miles from the base at a bearing of north 48 degrees east. Okay, so that's our situation. And I got two questions with this. The first question I'm going to ask is how far is the Coast Guard from the cargo ship? And then the second question I'm going to ask is what bearing should the Coast Guard ship follow to reach the cargo ship? Okay, two-part question. So that's what we got to work with. Okay. So first off, I need to have distances for both ships. And the cargo ship, I have a distance. I have 180 nautical miles. I don't have a distance for how far the Coast Guard ship traveled, right? I don't have that distance, but I can find it. I mean, we know that distance is how fast you're traveling multiplied by time. So in this case, we traveled 16 knots, which is nautical miles, multiplied by 3 hours. So we traveled 48 nautical miles, okay? So that's the Coast Guard. Now notice, that's gonna help us because when I draw my picture, the Coast Guard didn't go that far out, right? It only went 48, but the cargo ship went 180. So that distance is gonna be longer in my picture, okay? So that's gonna help us out. So let's look at part A first. Draw my picture here. So let's see, Coast Guard went 82 degrees. I don't know, something like this. Okay, so here's the Coast Guard, and I'll just call that C for Coast Guard. Okay, and this distance we calculated was 48 nautical miles. And then we have the cargo ship, which went 48 degrees, so it's smaller, and it went 180 miles. Okay, so that's going to be a lot longer. So I'll put B for the. It's so hard because Coast Guard and cargo could both have C, but I can't do that. So we'll say B is the cargo ship. I'll tell you what, because this is what happened to me in my lesson. I got the variables mixed up because they both got C's in it. So cargo ship is B, Coast Guard is C, okay? So we're not gonna make that mistake again. All right. And they traveled 180 nautical miles. So there we go. Okay, we'll connect them. So from here to here, that was 48 degrees. little coordinates, north, south, east, and west with it too, the directions. Okay, so the first part is how far are these guys? So I want to solve for this guy, okay? What I'll do, let me just put A here. So little a would be over there. So I want to find little a, okay? And to do that, I need to have an angle measurement, or else I'm dead in the water. No pun intended, but I am dead in the water. So notice that from the north-south line to this is 82. North-south line to the first path is 48. So if I subtract those two, I should get the angle that's inside the triangle, which is what I want. So that's going to be 34 degrees, okay? And now I can see that I have, I'll put it here, a side angle side case. So law of cosines is perfect for it because I can take the angle and the side I want to find as the opposite ends of the formula, which is over there. You can see it. And then I can plug the other values in. Okay, so I'll go ahead, I'll rewrite the formula. The more you work with this formula, the more you just start memorizing it. You know the pattern, you know what it's going to look like. All right, a squared I don't know yet. Let's see. B, I should have labeled this too, huh? B is this guy, and then C is this guy. So this is going to be 48 squared, 180 squared, minus all this stuff. Very technical, very mathy, all this stuff. Okay. Now, just like the prior problems, I'm going to leave myself a little trail. I'm going to go ahead and simplify some of this ahead of time so we get the following. Okay, so we're going to take the square root to both sides, and we get the distance between those two ships, 142.8 nautical miles. Okay, so there's part A finished for us. Not too bad. A clear picture does help, okay? Without the picture, I mean, you're kind of guessing as to what you're using there. Now, part B says, what bearing should the Coast Guard take to get to the ship, to get to that cargo ship? So let's do part B now. You awake? Stay awake. Don't fall asleep yet. You don't want to miss all this fun and excitement. All right, part B. Now what I'm going to do is redraw the picture. Okay, I'll draw it over here. So let's see, we have A. B's all the way out here. C was like right here. There we go. I'll put C like here. This was 34 degrees. Okay. Let me put, I'll tell you what. Not that that isn't important right now. Let me put the other measurements we started with, and you'll see why in a moment. So from here to here is 82 degrees. Okay. And let's see, this was 180. And this was 48. Okay. Now notice I didn't put that distance in yet. Okay. Well, why not? I say, notice how I did, and now I'm going to do it anyway. Oh well. Okay, so what bearing should this Coast Guard take to get to here? Let me go ahead and draw my north, south, east, west lines. Okay, so in other words, I want this little angle here. I'll call it alpha. I want that angle. Okay, what bearing should it take? And again, this is not drawn to scale, so when you look at these angles, you're probably thinking like, oh, that should be a smaller angle, and it probably is. But don't be surprised if it's not as small as you think, because again, it's a rough drawing. It just gives us an idea. So here's what I'm thinking, all right, just to kind of get the brain working here. If I figure out what angle C is, which alpha is part of, okay, and if I look at, let's take a look at this angle. Now, I can actually find this angle that's on the outside. Let me get, that 48's annoying. This angle and this angle do have something in common. They're alternate interior angles. So this angle right here is 82 degrees as well. So I'm going to put AI as alternate interior. Okay. And I do apologize. You might have to zoom in. Okay. But there is another, I'll put it right out here. There's another angle there, I'll call it beta. Okay. There is a small angle here that I got to figure out as well. But here's the good news. This forms, okay, if you look at the whole entire thing, let me make sure I'm saying that correctly here. Yeah, we're good. So this whole thing right here is forming, okay, 180 degrees, okay? We're looking at two linear angles. So what I can do is I can subtract the 82 from 180, and I get 98 is what beta is. And I'm running out of space. I mean, I should have drew this a little bit bigger, and I apologize for that. So beta would be 180 minus that 82, so we get 98 degrees, okay? Which is perfect. So here's what I'm going to do. Again, just to show you my thinking here. I'm going to take the entire angle C, which I'll calculate, and I'll subtract from there, okay? I'll subtract the 98 piece here. So if I take the whole angle, subtract 98, what I'm left with is this angle alpha, okay? And that's what I want, because that's my bearing to get to the cargo ship, okay? So let's go ahead and find angle C. Now, you have options. You could use law of sines, law of cosines. Because the title lesson is law of cosines, I'm going to use law of cosines. So I'm going to find angle C. And again, I'm going to rearrange the formula, but I'm not going to go through that whole process again of showing it. You already seen it once. So I'm just going to go ahead and jump down to it. But again, if you want to use the original formula over here, plug numbers in and simplify, be my guest. Okay, so let's go ahead and plug these numbers in. So let's see, little a is that one we calculated, 142.8. Was it 142.8? Yeah. Little b was 48. And then c, which was 180. And then 2 times 142.8 and 48. So we get, tell you what, just to save a little bit of space, let's do this. I'll jump to the inverse part. And let's do, there we go. So I simplify the numerator denominator like this, take the inverse of it, and we get the angle to be, well, that was weird, roughly 135.1 degrees. Okay, so that's the whole angle. So, alpha is going to be 135.1 minus 98 degrees, and we get 37.1 degrees. Okay? Perfect. So now all I got to do to finish this, okay, is tell me the direction. So if you look at my original lines, this is north, this is east. So the bearing that it has to go is north, 37.1 degrees, east. That's our final answer. Okay. So finding the bearing to get back to it can be a little tricky, and it does depend on your picture. Okay. So that can also be a little bit tricky as well. So, alrighty. And I don't know if there you go. Beta is that whole thing. My apologies. I didn't draw the arc fully. These would be linear angles. So I take my 82 minus 180. That whole thing is 98. Okay? So if I subtract the whole angle from 98, I get that 37.1, which is what I want. All right. Questions? Must be good because you're not talking. All right, last one. Let's use Heron's formula. Hang in there, we're almost done. It's a very quick little concept, okay? So it's not going to take us long. So Heron's formula Now, I'm not going to derive it because that makes this video even longer, but you can use law of cosines to derive this, okay? And this is to find the area of a triangle. There's so many ways to find areas of a triangle. In fact, if you remember from algebra, we did it with matrices too. So there's a lot of cool ways to do this. So given a triangle with side lengths A, B, and C, the area is given by the following. Okay? So A, B, and C are the side lengths, but you're probably wondering, what the heck is S? Well, let me tell you. S is the semi-perimeter. So you take your perimeter of the triangle and you take half of it. Okay, so that's what S stands for. So let's go ahead and use it. So our last example, find the area of a triangle with side lengths of 11.7 centimeters, 15 centimeters, and C is 7.9 centimeters. Okay? Now, I don't need to draw a triangle in this case, because if you look at the formula, I just need the side lengths anyway to calculate everything I need, so a picture's not really going to help us. So I need the semi-perimeter first before I use this. So we're going to take half of 11.7 plus 15 plus 7.9. And when we do that, we get 17.3. This is in centimeters. So there's a semi-perimeter. Now let's plug those values in to find the area. There we go. Okay. It's a lengthy formula, isn't it? When you plug all those values in, it just kind of keeps going on forever. But anywho, okay. When you multiply all those together, you get 2,094.5456. And we take the square root, you get 45.7 square centimeters. So there's the area for that guy. Okay? Not bad, huh? It's kind of cool. And again, this comes from using law of cosines to derive it, but just kind of a little cool tack on at the very end of the lesson. But Heron's formula, just to give a shout out, it's a mathematician, is where it comes from. I'll put it over here. So he was a Greek mathematician, so Heron of Alexandria. Okay, and he found this just using law of cosines. Okay, he was able to come up with another way to calculate area of a triangle, which is awesome, because not all the time you can have an altitude. I mean, you could draw an altitude, you can figure out what that is, but this is kind of eliminating that need for doing it. You can actually figure it out just based off of just 3 side lengths, which is incredible. It's a lot of fun. So thanks for hanging in there. Hope you're having a good day today, and that is it. See you in the next one.